But so Professor Barry Marshall, thank you so much for coming in today. I guess for people listening or watching, probably most well-known would be that you're obviously a Nobel Laureate. I think you won the Nobel Prize in 2005 in Physiology and Medicine.
Right, yep.
It's probably things you already know, well aware of. And if I'm correct, it was between your work and Robin Warren's work on discovering the causative relationship between, now if I'm pronouncing this right, Helicobacter pylori
Yep.
and gastric ulcers, gastritis, and to an extent gastric cancer. Is that sort of mostly on the mark there?
That's pretty right. So that's why it's important.
And are you also, I know that you also founded On Deck, which is something that you've been working on in recent years, which is an extension of your interest in the bacteria. And then furthermore, are you also a senior lecturer at UWA at the moment, or are you still affiliated with the university?
I don't do a lot of teaching anymore, but I'm clinical professor of microbiology is the official title. It gets flicked around. You want to get the right title so you don't have too much administration. So I have the right balance at the moment.
Yeah. Okay.
Yeah.
It's just getting into it. You were born in Kalgoorlie. Spent a lot of your childhood there, and also some time in Carnarvon. I was curious, actually, with Kalgoorlie, what was that experience like at that sort of time period?
Well, I was back and forwards in my first 7 years of life. So I did some time in Carnarvon, and then I did kindergarten in Fremantle when my father was in the crayfishing that winter. Well, that's the summer actually. And he was in the whaling in Carnarvon in the summer as an engineer.
Yep.
And then where did we go after that? Oh, then we went up to Kalgoorlie for a few years. So I then started school in Kalgoorlie, and that was a bit of an experience because you used to kids used to run wild in those days. They didn't have parents driving them everywhere. So you walked to school and home, got bitten by a dog on one occasion. Used to go to the pictures on Saturday afternoon. There were all kinds of larrikins and disabled people going crazy in the theatre and people throwing Jaffas, rolling Jaffas down the aisle. It was a real experience. And looking back on it, it was a pretty interesting life. We used to have Guy Fawkes night then, so everyone could buy fireworks. As a little kid, you could go and buy penny bombs and things down the shops and let them off in the afternoon. Oh, it's a wonder I survived it.
It's a Wild West. My parents lived there for a bit before they came to Perth, and they only wanted to get out. Yeah, that's all they wanted.
So that was a part of that. My mother obviously was a bit more. I guess she was brought up in Victoria and different gold places around the 30s and 40s, and so she wanted to get out of Kalgoorlie. She thought her kids were going to get killed, I suppose, the way things were going. And so then we grew up in Perth. My father was a refrigeration mechanic and a fitter and turner. He had a lot of tickets, actually, ultimately. Yeah. Diesel engineer, so he was an engineer on whaling boats. And my mother she started nursing, then she had the family, then she went back to nursing when I started medical school when she was 40. She did nursing for the rest of her life. And, so that was the environment I had there.
That's cool. Probably just a precursor to something we can talk about later as well is like the maybe, I guess, disparity between your more contemporary understanding of medicine and healthcare and then your mum's background in nursing and how you guys might have had different views on certain points and things like that. But we can talk about that a bit later.
Yep.
But so growing up in Kalgoorlie was interesting to say the least, and I guess moving forward in time a little bit, the kind of culture there, I suppose, it was uncommon to leave the town and go and study at university. That was
so there were very few kids, I suppose, who did medicine out of university. I remember someone we knew, their son had got into medical school, but even going to university in those days was pretty rare
Yeah.
somebody from Kalgoorlie. Although School of Mines was like a curtain university up at Kalgoorlie. I'm not sure whether it's still there, but if you had anything that was high-level trades, you could do that. There was a massive railway workshop there when my father did his apprenticeship, because they used to change from the standard gauge to the narrow gauge in Kalgoorlie in the middle of the night. And so there was all kinds of workshops and industries in Kalgoorlie related to the train back and forth. So it was a pretty good place to, I guess, learn skills, trades, etc. And it tended to be protected from the ups and downs in the economy. So when the Depression was on, apparently, if you could get a job in the gold mines in Kalgoorlie, a related job, you were protected from the Depression. You weren't on a soup kitchen or anything like that. You continued to earn fairly good money. So Kalgoorlie was one of those places that was protected in the 30s, I think, until the World War.
Yeah.
One of the other jobs that generally gets protected during a downturn is sign makers.
Sign makers for sale.
Yeah.
I hadn't thought of that. I suppose pubs is the other one.
Yeah, that's true.
Recently, my parents are elderly now, in their late 80s. But about 10 years ago, we had them do their oral histories of their childhood. And, you really get the feel of what goes on in those days. And my father, he was a paper boy in Kalgoorlie so he was sort of young teenager and paper boy during the World War II. And all the Americans used to get on a train in Perth or something and go to Melbourne or back and forth. So there's a lot of American soldiers travelling back and forth who had no idea what 2 bob was worth in Australia. So it's some kind of a coin, It was like a day's wages. And so he was selling newspapers and getting like 2 shillings tips and things like this. And he then franchised parts of his paper round because it got busier. So I think he had 3 or 4 paper boys kind of working underneath him. And he was earning, as a kid in school, he was earning an adult wage.
Good Lord.
So he was earning a couple of quid a week.
Yeah.
And so all kinds of interesting things happened during the war. And then my parents, I guess, got married in 1951, and then right after he had his apprenticeship finished, I think.
Yeah. What do you think it was? What influences in sort of that environment in Kalgoorlie? Where did the spark, I guess, come from for you to go to Perth and study medicine at UWA? What was the influence? Because I think it would be maybe accurate to say that your mum probably had more formal academic experience, but your dad seems to be quite entrepreneurial and very intelligent and switched on. So I'm trying to work out who was the major influence there.
So my mother was more level-headed and I don't know. I suppose it's not politically correct, but I do think women are a bit more skilled at planning.
Oh, yeah, definitely.
My wife's much better than me at planning. I'm like, my horizon's about 24 hours and hers is maybe 24 weeks.
Yeah.
So a bit of that goes on, but there was a good balance of a skill set. Of course, my father was a top tradesman, and I think in those days, a lot of people didn't finish high school, went into a trade. And so there was all kind of skill sets and levels of people in the trades. And clearly some people were able to read the technical books and study and get other tickets. And so my father was pretty qualified by the time he was in his 40s, and he was a foreman running an engineering shop. And my mother looked after us, but she had nursing books, anatomy books, and physiology, as it was known in the 50s, I guess. And my father had engineering books, so I had access to electrical, electronics, mechanical engineering, thermodynamics, because it was refrigeration, so all those things. And so that's what I was, and I don't know whether anyone else remembers what it was like when you couldn't read.
Yeah.
And you just wanted to learn stuff. You didn't have podcasts, you didn't have YouTubes or anything like that. So the only material coming into a house might have been the newspaper and what you saw on the movies and what your parents had lying around. We didn't have a lot of books, but we probably had 10 or 15 books that were tended to be technical.
Yep.
And so I read every book in the house from cover to cover as soon as I learned to read. So by the time I was 8, I was there, right, what else is there?
Yeah.
And so getting into school, reading all those, nature magazines and things that the school had a little library, etc. I used to read all those as well as the school books. So, I loved school and I was very interested in science. And I think my parents are more, I don't know how I would say it, but interested in the facts, data-driven. And so I never knew anything else, although we had religion and we were Catholics, used to go to church and everything. But, as I got in my teenage years, I started thinking about this. And I was, how exactly could that work? Geez, must be a miracle. But, gradually that weakened as an influence on my life. And by the time I was in high school, I was interested only in science and math and English. And it's something that I could see was going to have an actual physical outcome for me. So it was a bit starved, if you like, from culture, because if you do high school and do the solid subjects, the maths A and B and
physics, chemistry.
Physics, chemistry, and English. Those ones. Well, then you miss out on maybe history. It's not a priority, although I did it. Didn't know too much about it. Geography and languages. Yeah. I was a bit lucky because I did Latin and I dropped that the second last year of high school, and my mother was just crying because she was right. I should have kept it up because I could have passed it in retrospect. When I saw the exam, it was so easy. It was just a passage from the Bible that you knew anyway. You translate that.
Yeah.
So getting into medical school, and then the medical school in Western Australia was 5 years of just science and medicine, anatomy, physiology, all those things. And you got out the end of it, you were, okay, you could do medicine.
Yeah.
You couldn't really do much else. You couldn't go and converse with the average person in another country and talk about my Shakespeare or, art, things like that. Luckily, my wife fills in that gap in my life, and so I tag along with her. And I'm always very impressed about the depth of knowledge and the richness that's out there that's not actually science.
Yeah.
So I appreciate it a lot, but it's not something that I was trained in.
Yeah. And your wife, you met her while you were studying, and she was studying psychology. Is that?
So she was kind of the opposite. She went to a nun school.
Yeah.
And the nun said, well, we're just nuns. We can't really teach very high-level maths she actually had a good maths teacher, I think, but we can't teach much sort of chemistry and physics in this school. And you say a limited repertoire of those kinds of subjects in the Catholic school she went to.
Yeah.
It was Mercedes College in the city. So it was
my sister went there.
It was premium. It was, in some ways it's good. Some ways it's a bit dodgy from the sound of it.
Very intense.
Yeah.
It can be.
But she was a good student and went to university and did psychology and did honours and education degrees, and she's then got she got more degrees than me. She's got a fine arts degree at Curtin and honours again much later. So she has all those kinds of skills. Plus, she was, I think in her TEE, she got the top score in maths at her school. So she could do that kind of stuff if she feels like it.
Yeah. Yeah.
Now, she's actually president of the Art Gallery Guides, the West Australian Art Gallery. So she does activities related to organising 75 volunteer women.
Yeah.
To do the guiding. It's good. That's what she likes to do.
Yeah.
So at an event, and you meet people, she's the lead when you meet new people at a party or something like that.
Yeah, it tends to be. Sure. She sort of has more activities on now than I. Well, I don't know, about the same, I suppose, but it's a bit hard to all go to each other's.
Yeah, I could be like that. Yeah.
So at the university, so now later I went to the University of Virginia, which had an undergraduate and then a 4-degree postgraduate degree. And I felt that was a better experience for medicine and training in medicine, because you would usually do a science degree, although it didn't have to be science as your undergraduate. So you might do biology, maths.
And the undergrad would be about 3 years? Or?
Yeah, it'd be 3 years minimum. And then a lot of people they wouldn't exactly take a gap year, but you'd be like 21 and reasonably skilled with a ticket, if you like, and you could then do an internship or whatever you wanted. Or you could just be a technical assistant in a lab for a year, see if you liked it, get a bit more experience, and then after another year or two, get admission to a good medical school with some credentials.
Yeah.
So in the US, it's very important to know, which university you went to. So in Australia, it's not quite so important because university is in quotes free. Yeah. I mean, you don't have, it's not so dependent on how much money you've got. And they're all pretty high standard in Western Australia and around the country. So in the US, you might work for a couple of years after your undergraduate degree, get some credentials from your boss, and maybe get a co-authorship on a paper if it's a scientific thing in a university, and then get a good admission into the clinical program 4 years. So you've already proven yourself at that stage. And I thought, and we would see trainees and medical students and doctors that had all kinds of other skills.
Yeah.
When they're interviewing, and often you say, well, my trick was I'd look, well, as far as his CV, he's got all the skills there you need to be a doctor. Plus, hey, he's a musician, or he runs tours to the Andes in the summer holidays or something, stuff like that. Well, that's interesting.
Yeah.
Sign him up.
So they know they have,
or her,
creative thinking skills and people skills.
Yeah. So you it's a bit more interesting, a bit more colourful. So I think now we've got an undergraduate and a postgraduate school in Western Australia, and there's pros and cons to that. But it does seem to me that the medical students I see are a pretty well-rounded bunch.
Yeah.
Yeah, they make you do subjects from whatever field that you're not studying.
Yeah, so you're supposed to do 1 quarter. In Virginia, it was 1 quarter of your subjects had to be something else. Mm-hmm. And so you might do philosophy, psychology, something, history, language, who knows. Yeah.
I know you talked about your experience at med school, that you sort of said that as long as you were better than at least 10 other students, you were all right. So there was like, it was, I guess, quite competitive in that respect. But do you think the model of doing an undergrad and then a postgrad with maybe some time of getting some life experience and working experience sort of guarantees or gives a better success rate than going on into the postgrad? So people have got that sort of, they've got some skills that they might not otherwise have picked up if they'd just sort of gone into a course and run it for like 5, 6, 7 years or whatever it is.
It probably gives you some skills that you can use in medicine that you might not have had. And clearly one of the main skills is talking to people and getting the information out of them about their illness.
Yeah. And
I was lucky I had that skill. Maybe I learnt it, but I just naturally could connect with people. And I sort of have a formula now that I can teach the medical students. And I see patients now in China, and they're like, well, why are you asking them that question? And the quality of the information you get back is much better if you've got a sort of a emotional connection or empathy with the patient. And so patients appreciate that, and they relax a bit, and you can then figure out what's the most important thing. If you've got 10 things wrong with your arm, they're like, okay, what's the one thing that I can fix today?
Yeah.
Let's focus on that and not spend 2 hours going into the past history of all kinds of other stuff. So you can be more efficient if you can relate to people, and hopefully you can find a common interest of some sort, or somebody that you know, or something that you know that they also have an experience with.
Yeah. So you were quite practical and diagnosis based, and I wonder, obviously your dad being a fitter in turn and having a lot of trade experience, and you often talked about how you would sort of tinker around in his workshop and get to play with a lot of different things. And in my past I've worked with fitters before, and they have a very unique mechanical kind of troubleshooting mind that very pragmatic and like looking at things objectively and seeing what the issues are, and they're quite very good at like very quickly figuring out what the possible faults are and how they can fix it and things like that. Do you think that kind of experience of tinkering and playing with like mechanical things and your dad's experience as well as a fitter kind of translated a little bit into your approach towards patients in medicine and healthcare?
Yeah, so with that, I suppose if you're going to be a fitter or a mechanical engineer, you want to have a good spatial concept of how things fit together and work. And everybody loves to do that. So if you're putting together a jigsaw puzzle or some toy or something, and these days, of course, you could have access to 3D printer.
Yeah.
And these, my grandchildren have got this gear in their high school, and they've got 3D printers, and they've got laser cutters and all kinds of stuff like this, and you do it on the computer and you go and make it. So that's the ultimate combination of that. Everybody can do it now. But in medicine, once I was getting a bit cynical about it as I was doing my training and everything, I thought, surgery is really just plumbing.
Yeah.
What is the body? It's got muscles and bones. So there's a bunch of pipes going everywhere. They get blocked up, they break, leak, all kinds of things. So this is abdominal surgery. And that was pretty interesting. And you could be almost a mechanical engineer of the body, if you like, if you're a surgeon.
Yeah.
And then, but what I felt was that there were some things in medicine that were great and pretty exciting, but sort of limited as far as the intellectual skills. So you might be a great surgeon. You can do a liver transplant in 2 hours instead of 4 hours. Fantastic. Well, you can get a job in a big hospital, do just liver transplants, and you'll be a hero and you'll save lots of lives and everything. But you need somebody else who's looking at the blood chemistry and saying, this virus is causing more trouble, or this patient needs more clotting factors, all those kinds of things is a bit more difficult. So that's what got me into internal medicine. So in medicine, you do occasional things like put in pacemakers, but really you're interested in the electrophysiology of the cardiogram to know which pacemaker is going to go in. Once you've solved that problem, you could get the intern to put the pacemaker in.
Yeah.
So internal medicine is more of a challenge. And although people say, these days, everybody, infectious diseases are treated, so you don't have, people tend not to get better. They have a lot of chronic illnesses, so it's mainly old people. And so if you're in internal medicine at Royal Perth Hospital or Hollywood or somewhere, most of your patients are 70, 80, 90 years old. They're having things patched up. But intellectually, it's a great challenge because they don't just have, the rules are if your car breaks, for example, it's one thing. It's going great, then it's not going great. So there's one thing that broke. But in a really old vintage car, you fix one thing, you put a strain on the next system, and that breaks or starts causing problems. So old people are like that, and they may have 3, 4, or 5 different medical problems, and you can't just go in and fix one thing with it and ignore the other 4. You have to have the right balance, and really good geriatricians do this. You don't just charge in with the strongest drug on day one, give the maximum dose, because you've got to worry about the kidneys and the heart and the stomach ulcers, things like that. So you would want to get the right balance. And so it's some ways you look in the hospitals these days, it seems that a lot of elderly people lying around not doing very much. But you've got to actually fine tune. It's like a fancy radio or this mixer thing you've got there. You got to fine tune 5 or 6 different little knobs and get everything in balance and try to get the patient back to where they were. So it's quite a challenge to do internal medicine.
Yeah, to not compartmentalize a problem and think about the whole system.
Yeah.
Yeah.
And also, and what makes it all economical these days is that you have your general practitioner who sees you, and in some ways, things can slip through the cracks because something gradually develops that even the doctor might not notice it until you point it out. But on the other hand, he sees how you function, sees you in daily life over a few years, and figures out what's appropriate for you in your social situation. Whereas if that person then goes off and goes to the emergency room and sees a young doctor who's read all the latest technologies and everything like that, might not get the best care that's appropriate for that person. And so it's very efficient, the Australian system, to have the GPs seeing the patient and knowing the patient, and then acting as gatekeepers to get the high-level latest stuff. Like if I was a GP, I know about thyroids, but I don't know the final detailed stuff about which is the best drug to do, what the various high-level tests mean on thyroid function, whether you should have radiotherapy or X-rays or, have the gland out, all those subtleties. Yeah. That's special stuff. And so the GPs at least direct the patients where they're needed. So it works out pretty well.
Yeah.
I had an interesting case. I kind of had the opposite thing happen to me. I have asthma, and I went to the GP and was given an inhaler for about a 5-minute sort of appointment.
Yeah.
And then a few months later, I was hospitalised, and at the hospital, I was given all the asthma information that I'd never got at the GP.
Yeah.
I never knew about a spacer. I never knew I was supposed to be on a preventer. Yeah. And I think just the main thing there is that I spent more time at the hospital. Yeah. And at the GP, they just were time constricted.
That's right.
And didn't have enough.
Well, asthma is one of those classic disorders that can be undertreated.
Yeah.
Because you're worried about the bad exacerbation. You're not worried about the fact you got a bit wheezy when you went out into the cold air.
Yeah.
You've had that all your life. And so you have your baseline treatment, some kind of low-dose steroid or something like that. And then you have your puffer. You have one in the glove box of your car, one in your pocket, one at home, so that wherever you are, you could get hold of one. Actually, I trained, did my first few years after graduation at Charles Gardner Hospital, which was the chest hospital. And so we used to just treat asthma, all kinds of chest diseases on a daily basis there. And then when I moved to Royal Perth Hospital, they weren't as good at chest disease, I didn't think, because they just didn't see enough of it at Royal Perth. We all went to Charles Gardner. But Royal Perth was great for cardiology and open hearts and things like that, and major trauma. So I ended up getting both.
Yeah. Asthma is an interesting one because I always, as a young person who works out a lot, when you then get exercise and do asthma, you feel like your own body is betraying you. But I want to go internally into my own system and give a talking to my immune system and say, hey, it's just dust. It's just like exercise. It's fine. It feels very frustrating to be betrayed.
So my knowledge of asthma, there's lots of people in my family have a little bit of asthma. My wife used to get it more so, but she carries a puffer and occasionally goes on a steroid. And I know that 20% of kids in primary school carry puffer for sports days. The other thing is that I'm an unofficial expert on this thunderstorm asthma that they had in Melbourne. All those people, 7 or 8 people died.
Oh, I did read about that, yeah.
And the point on that was that lots of people with mild asthma suddenly got lots of pollen. And the right humidity and everything, the pollen granules, the pollen splits into about 800 little tiny granules of starch that get right down in the deep ends of the lungs. And then, so the ambulance system in Melbourne was overloaded. They didn't communicate properly with everybody. So, the ambulance will never say exactly how long they're going to be. That was one thing. It was overloaded, and people who had very mild symptoms most of the time and didn't have a puff or any rescue medication suddenly had life-threatening asthma.
Became hypoxic. Yeah.
And nobody had anything that they could give them. And instead of whizzing them off to the hospital, the people who died because they were lying on the front lawn or somewhere waiting for the ambulance, and they died. Once they got to the emergency room, they pretty much all survived. So it was a crazy system. So at least these days, more and more we've got mobile phones and communication. So, and I'll say that the communication system, if it's reliable, probably saves more lives than anything else we've got going for us at the moment. You know, you really feel safe. 20 years ago, if you missed an appointment or you got the directions wrong, you couldn't meet up with somebody, you couldn't communicate. If your car had a flat tire in the middle of nowhere, what could you do? It was a disaster. So now we're much, much more efficient in health as well as everything else.
Yeah.
That thunderstorm thing terrifies me, because the people in the emergency department told me that the thing they fear the most is someone coming in hypoxic from an asthma attack, because you can't give them painkillers, obviously, or anything like that. You just have to.
Well, I've done it. I've been on the receiving end of people with, near terminal kind of breathlessness.
Yeah.
So the scary thing is you have to anaesthetize them and paralyze them. So now they can't breathe at all. And then you've got 30 seconds to get a tube into their lungs, which is a skill. You say, what if I can't get it in? This person, what am I going to do? So luckily, I was skillful enough to always get it in.
Yeah.
But that's probably the mechanical engineer in me. I know anatomically where things are, and they can't be anywhere else. So I just keep trying. And but you've got to get that tube in, and then you've got to ventilate the patient. But to get them ventilated, you've got to they got to be paralysed and anaesthetized, at least initially.
Yeah. And they might not recover as well from that whole ordeal as well, don't they? Sometimes there can be brain damage.
Well, yeah, but once they get to the emergency room, you get that tube in. You straight away got rid of a lot of the dead space out of the mouth. So when you breathe in and out, there's 100 mils or so of air that's coming out of your lungs and into your mouth, and then going back down into your lungs. So it's wasted. If you can put a tube in so that you're delivering good air or oxygen or something right down into the lungs, you see you've got 150 mils of dead space probably, which is gone. And so you don't actually have to move quite as much. In fact, I believe that if you get a fine tube that just delivers oxygen and get it down into the lungs, into the bronchi, and just run the air there, it's enough stirring around to keep you alive even if you weren't breathing.
Right.
Okay, yeah.
Anyway, so interesting. But I don't want to think about that because it's scary for the doctors as well. Doing your best and say, what if? Actually, my daughter just did her intensive care exam on Tuesday in Melbourne.
Okay.
And so she's very skilled at all that kind of stuff now. But of course, she would tell me that she still puts the hairs up on the back of her neck when she's seeing someone in a life-threatening situation. You've got to do something immediately and save their life. So one great thing about winning the Nobel Prize, I spoke to the boss at the university and said, I don't want to do on-call anymore. I said, I've been carrying that burden every time your page or your phone rings after hours. She's like, oh, God, what's happened now?
Oh, yeah.
So it's great not to have to worry about that.
I hate receiving...
You just want to keep that.
Yeah.
Sucker just up there.
I hate receiving phone calls and emails just in general, so I can't imagine receiving something like that.
I just avoid these group chats.
Oh,
Somebody signs you up. Next minute, you're getting CC'd on about 20 different things a day. I said, right, if you send me anything with CCs on it, I'm just going to delete it. I'm not going to read it.
Yeah. That's enormous pressure, though. What you were describing there, that's
We don't have to keep talking about asthma. That tangent sort of brought back flashbacks.
Yeah.
Sort of moving into the Helicobacter stuff and your research and subsequently the Nobel Prize. I want to establish the context of the treatment, diagnosis and treatment of gastric ulcers, gastritis, and what the pharmaceutical marketplace looked like.
Yeah.
Because I think that's
So it is an
very
interesting. There's several Nobel Prizes connected to ulcers and things. The technology. Well, I can tell you that I used to see patients who had a psychiatric diagnosis.
Yeah.
And I was getting to this stage where I got the feeling that if we couldn't figure out what was wrong with you, we'd send you to a psychiatrist. So just because we can't find the diagnosis, therefore you must be crazy.
Yeah.
The assumption behind that is that every possible diagnosis is there on that list. And if you've ruled them all out, there's nothing else. Those diseases don't exist.
Yeah.
We haven't discovered them anyway.
Because the expert can't be wrong, or
That's
can't be
right.
at a
Well, you've
loss.
got this massive medical book, and it's got a list of the 28 causes of diabetes, for example. And, well, you can measure the blood sugar, so you can't argue with that. So once you've gone down to 28, well, it must be a slight combination of 16 of them or something. That's all you could say. But with ulcers, they had suddenly become a problem at the end of the 19th century and built up in the 20th century. And certainly places like Chicago, where they had a bit more technology and used to do a bit more surgery and everything. So they were aware of bleeding ulcers. Before 1900, if you had a bleeding ulcer, you could never really diagnose it. So sometimes he vomits blood, he looks pale, has black diarrhea, there's blood going through there. And at post-mortem, we found an ulcer. That's all you could do.
wow.
So they had this thing, but in those days, say before 1950s, if you like, more than half of medicine was just superstition and instinct. And because we didn't know the cause of all these different diseases. For instance, women with thyrotoxicosis, like hypothyroidism, so you get hyperactive, fast pulse, your eyes can get bulgy, that sort of thing. So it's more common in women. Immune disorders are more common in women, but young women who got thyrotoxicosis, it was some kind of variant of hysteria.
Right.
They were mad. And so I don't know what the treatment was in those days, but of course you could die from it. And many other things that were a bit emotional had an emotional component to it, maybe secondary to the illness. It was blamed on the emotion and the illness followed because you didn't really know what the illness was. And ulcers were like that. So in the 30s, and also there were these people like Sigmund Freud. Most of what he wrote, he just made up.
Yeah.
So Sigmund Freud, he was the gospel, you see. And anybody who got an illness that you didn't know the cause of, you'd find, oh, yes, if we ask him enough questions, we'll find out that really secretly he hated his mother or he loved his mother or something.
Yeah, it was all sexually related. Yeah.
So all those things were there. And there was another guy called Jung, who was Sigmund's offsider, and he said, a duodenal ulcer is the hole through which a man crawls to escape from his life.
It's the manifestation of his shadow self. That's
That kind of stuff. Yeah. And so ulcers were in some ways respectable in that it meant you were a type A personality and you're a hardworking businessman and you're in control, and because of that your emotional level was a bit higher, you're a bit tense and a bit cranky, and you'll get this ulcer because that would raise your acid level, and acid caused ulcers. There's no doubt if you had no acid, you didn't get an ulcer. So therefore that must have been what caused high acid levels.
You could put it on your resume.
Yeah.
I'm prone to ulcers.
And so, yeah.
I'm productive.
Prone to ulcers and you're a heavy smoker, great. We'll put you in sales. That's probably true.
Yeah.
So that kind of thing. So when I specialised in ulcers, I used to see lots of people like that.
Yeah.
And there did seem to be a subgroup of people who were really living life at 200%, and they would drop dead from something, but they already had 200% for that 40 years. So it didn't seem like a bad deal in some ways. So you had this emotional thing, but of course you would meet people who had ulcers and they gave up all the stress out of their life. They retired, they sold their business, they took a holiday to Italy on a cruise ship, still had an ulcer. So what could you do? So I was susceptible to anything else that might cause ulcers rather than just stress. Because most of these people I saw with ulcers, they just seemed like everyone else I knew, except maybe if you had a pain in the stomach every second day and occasionally vomited out of the blue, you would feel a little bit on edge, wouldn't you? You don't know whether you're healthy or not. So Dr. Warren, in 1979, he's not like me. I'd like to have about 10 projects on the go in the hope that one of them will be successful. The other 9 fall by the wayside. Dr. Warren, he liked to focus on something. And so he's a good pathologist. He's not going to miss that one cancer cell in your biopsy. He'll see it there. He'll say, get another biopsy, get another 500 sections. I want to see where that came from. What is it really a cancer cell? So he's like tuned into that. And so one day he saw these bacteria and he said, well, I've never heard about these bacteria that I'm seeing on this biopsy. Is it a strange thing in Western Australia? How do they live in the stomach? And he was asking his colleagues about it. And they said, well, there's literature there. Bacteria grow in endoscopes. And sometimes we see them all over the place. They're just contaminations. But as he collected a few patients, he saw that they were identical. There were certain bacteria, they looked identical, so they're like a flattened out S shape. So they're called Campylobacter, which means curved bacteria. And so they were, if you like, homogeneous. So whenever he saw them, they all sort of looked the same, stuck on the surface of the stomach. And he had, over a year or so, he collected about 20 patients who they were being checked for stomach cancer. They might have had an ulcer or they might have had red stomach or something at endoscopy. Someone decided to take a biopsy. Warren occasionally would see these bacteria. And so he was interested in it. He showed it to his colleagues and they said, oh, don't worry about it. I've seen them. They're nothing.
So people disregarded it because it was common just to see it.
And it wasn't in the books. The inflammation that's associated with the bacteria, there's quite a few papers written about gastritis, which is inflammation of the stomach. But no one recently had really thought about the concept of inflammation in the stomach after a while could lead to an ulcer. And so there was when we started our research, we found fabulous things in the literature about this. I'll tell you some of the stories. But so I was looking for a research project, and the great thing in Western Australia and the College of Physicians in Australia is the trainees. So you pass the paper, so the basic is there, and you've got to do training jobs for 3 years so that every 6 months you get moved around in the public hospitals typically. So I was doing those jobs, and each year you're supposed to try to find a case report or some kind of research or tag onto someone who's doing funded NHMRC research and be their clinical assistant, that kind of thing, as well as your normal job. So it's a bit extra if you want to do that. So I was doing different things, and my boss said, Robin Warren's always talking about these bacteria, and why don't you, he's got a list of patients. He wants to find out, who are these people? Is there something that they're doing that's causing these bacteria? It might be interesting. And there was no connection with ulcers at that stage because a lot of these people didn't actually have ulcers. And so I was interested in, because my dad was running a chicken factory, and one of the contaminating bacteria on fresh chickens is Campylobacter. So it was a hot organism in those days, but not pylori. It was a different one. And so I thought, oh, this is great. I'll do some research on this. I'll tell my dad about it. The chicken industry, they'll be pleased to see some research on Campylobacters, and they'll probably give me funding. I can do research. So I had this dream. But of course, it's not going to happen because the chicken industry doesn't want you to be finding harmful bacteria in chickens.
They don't want people to know that.
They didn't want to do any research on their chickens. So I worked with Robin Warren, and one of the people in his list who had the bacteria in the stomach was a woman who had been on my ward, and she always had stomach pains. She occasionally vomited. She was really miserable. But really, we couldn't really find anything wrong with it. The only thing was that when she had her endoscopy, the stomach looked a bit red. Gastritis, very, very common, harmless condition. and the biopsy showed the bacteria, and she was one of the 20 or so that Robin had in his list. And so I was impressed by that because I remembered that woman well, and I had taken a history of her on a number of occasions, talked to her family, try to find out what was wrong with her. We couldn't figure it out. And of course, at the end of 2 weeks in Royal Perth, she was sent to a psychiatrist to get an assessment. Why is she so miserable? She's probably just depressed.
Yeah.
You see, she imagined it. And so she went to the psychiatrist, and the next day went home, you see. And I was there like, why would you send her to a psychiatrist? She just seemed like everybody's mother, just a normal person as far as I was concerned. So she was about 50. So, who am I to say? I'm just a trainee. So, but these things add up. And so when I saw her in that list, I thought, gee, maybe these bacteria are doing something. So I was quite interested in it, and I was interested in the fact that all the bacteria were the same. So from my microbiology, I knew that if you look at the bacteria in the mouth, there's purple ones and pink ones. There's fungi, there's rods, there's straight ones. There's chains of them and cocci and little clumps, all kinds of different ones. You don't get a pure type of bacterial culture out of the mouth. If you do a mouth swab, there's different coloured spots all over the Petri dish.
Entire ecosystem living in your mouth.
Yeah,
pretty much, yeah.
That's right.
Yeah.
So biodiversity, if you like.
Yeah.
And so, but in the stomach, there's nothing there but acid. And the literature would say the stomach is sterile because if you suck the acid out of the stomach and put it on a Petri dish, nothing grows because acid kills bacteria. That's why you actually have acid.
Yeah.
You have to sterilize your food before it gets absorbed.
That's what I was told a couple of days ago in one of my classes. They were like, oh, in the stomach, no bacteria grows there. And I was like, I don't know about that.
Right. So it is kind of true, except for the fact that's assuming that you've got a method which would culture every possible bacteria if it was there.
Yep.
You can now use this method to look in the stomach. But of course, no one had cultured Helicobacter. So they could never culture them, no matter how many there was. And so they would think it's sterile. And they would ignore the fact that they could see these things under the microscope, and they were present on electron microscopy in different places. But everyone's like, it's a contamination, it's nothing, don't worry about that. Scrape those bacteria out of the way. We want to look at the ulcer underneath, you see.
Yeah.
So that was the mentality. And so Robin and I spent many hours together looking down the microscope at these bacteria and then searching the literature. And one of the clues that got us into it was these kinds of bacteria, similar, were quite well known in the veterinary literature because you see, in animals, you can euthanize an animal, do a quick postmortem, you get a fresh specimen, and beautiful photographs for your histology and electron microscopy. You can see these bacteria there.
Yeah.
And so everybody in people who thought about it knew that in dogs and cats, they had spiral bacteria living in their stomach. So they're not aware that, gee, it'd be strange if the human stomach was so sterile and clean. And every other animal known to man has got some bacteria living there that look like that. So then we traced these things right back, and we got back to 100 years ago. These things were described in the literature, and in the 20s and the 30s and the 40s and the 50s and the 60s and the 70s. And time after time, people noticed them, wrote a little paper as a junior researcher or something, took a few photos, and they moved on to their careers because nobody had thought that they could be connected with ulcers. Now, one of the smoke screens that happened was that ulcer drugs came on the market called H2 blockers in the, say, 76 or so. So the chemist so pharmacology started to boom about 1970. And this was the concept of you looking at a drug and then you've got a receptor, activate something in the cell pathway, the cell does something. So, insulin is the classic one, puts glucose into the cell. Then there's things like growth hormone and all these different hormones, plus blood pressure treatments. And so one of the blood pressure treatments that came out of this, well, actually one of the big ones was asthma treatment, which is a beta receptor stimulator,
Right.
So there's beta 1 and beta 2. Some are in your lungs, some are in your blood vessels. So beta agonists were Ventolin.
Yep.
And I can't remember the names. Xylomethazolene, nasal decongestants is another one, similar type of thing. And that might be beta 1 or beta 2, I can't remember. But it no good for asthma, but it'll dry up your membranes in the throat. So those kinds of receptor things happened. Beta blockers is the
Anxiety.
opposite. Yeah, adrenaline. But they would give you asthma if you took a beta blocker. Right. But it turned out to be good for arrhythmias, heart, blood pressure. And then, there's other beta receptors. And there's histamine and histamine receptors. And there's histamine receptors in the stomach. If we block those, you can't make acid. Mm. So the histamine blockers came out, and that was Tagamet was the first one. And then Zantac, ranitidine came out. And so by the time I came on the scene with Robin Warren, these things were billion-dollar drugs. They were the first super blockbusters, if you like. So now a blockbuster drug is anything that sells more than $1 billion.
Yep.
So pharmaceutical companies aren't even interested in anything less than that these days because it's so expensive to make drugs. So the acid blockers were there. And after a few years of using these for people with bad ulcers, they were so expensive. It was like $5 a day. Potentially for years. So the government used to pay for them only if you had an ulcer. So you'd have to have an endoscopy. If you had an ulcer, you get the drug from the PBS. So the H2 receptor blockers, acid blockers were there. They used to heal ulcers. But if you took a biopsy of the healed ulcer of the stomach, the bacteria was still there. So clearly the bacteria are not causing ulcers, right? They're just a coincidence. So it was the smoke screen was there. However, after a couple of years, they noticed that whenever they stopped these drugs, the ulcer came back. So the thing that hadn't been changed was the colonization of the stomach with the bacteria. So that argument that it was the acid that was primarily the issue sounded a bit weak when I looked at the literature. I said, well, looks like there's something wrong with your stomach. It's not, the acid's there, that's normal. How come, most people have got plenty of acid, they don't get ulcers. So it's something else. It's the lining of the stomach's weakened. And Robin's got these photographs of the bacteria, all the cells are sort of separating and little gaps forming between them because you can imagine then the acid be leaking. And white cells are coming up from below, from your bloodstream, and wiggling their way between the cells and opening the tight junctions and coming up into the stomach to eat the bacteria. And so that each time a white cell goes through, obviously for a few seconds there's a little leaky part there, and the inflammation by itself. White cells are releasing all these chemicals to kill bacteria. So the ultimate pathway in a white cell when it's killing a germ is pool chlorine. It's hypochlorite or something that's in a little vesicle in the cell. So the white cell has to eat the bacteria, put it inside a vesicle, and then inject superoxide radicals and things into it and kill the bacteria. So that's what's going on.
Yeah.
So you can see that would damage the lining in some way.
It's becoming too permeable.
Yeah, it's too permeable. The acid's getting in, and so it's all upset. So thinking about that, not really surprising. It's a pretty good hypothesis that was really the underlying problem. But the curious, there are a lot of curious things, red herrings about ulcers. You see, Robin and I were testing lots of patients, taking biopsies, and we could say the strongest colonization with the bacteria was in the stomach. But the strongest link to ulcers was with duodenal ulcers, which was on the other side of the pylorus. It's a bit away from the stomach. So it's like, well, you have to have the bacteria to get a duodenal ulcer, which is the most fatal, dangerous kind of an ulcer, very chronic, and the one that's associated with stress and everything. So everyone's there, well, why these bacteria cause gastritis, but we don't see gastritis in people with duodenal ulcer. It's not associated with gastritis. And I said, hang on a minute, I've read something interesting about that. And so back in Minnesota in the 1950s was this beautiful paper written by someone at the Mayo Clinic. And you see, the problem with people is that if you die, and I say, okay, well, we're going to do a post-mortem. The post-mortem happens the next morning, by which time the stomach's half digested itself. It's full of acid and enzymes and things. So if there's bacteria on the inside wall of the stomach, you can't find them. They've all popped and ruptured and everything, and you just saw a slimy mess there.
Yeah.
So they were not seen. No one was aware of it. However, in Minnesota, what happens to you if you have a car accident in Minnesota in the winter?
Yeah.
You are snap frozen.
Yeah.
Especially in the 1950s, nobody had a heater in their car and things would happen. So that they had a whole lot of road accidents. No one had seat belts in those days.
Oh, yeah.
They had a great road toll, and they had people who'd been snap frozen who then had postmortems, and someone had looked at everybody's stomach. And he said, well, whenever I found a duodenal ulcer, I found gastritis in the stomach. So it was like almost 100% correlation between the two. And you couldn't argue with that. This person had no axe to grind about ulcers or no theories or anything. He's just a pathologist reporting what he found.
Yeah.
So I said, I believe that Minnesota study on the snap frozen young people, even 20-year-olds, you see, not just old people dying with other things. So that was a classic thing. So there was evidence like that in the literature that we found. So after 6 months or so, I sat down there with Robert and I said, look, now that we're looking at all this stuff, we've got all the data and we've studied people at Royal Perth, I think this bacteria causes ulcers. And Robin, whoa, gee, that's a bit of a jump, Barry. I said, yeah, but it could be quite important. I should stop what I'm doing and just change my career just to study this. I'll try and get a research grant and find out. We'll treat people with antibiotics and see what happens. And so that's really what happened. It took a couple of years before I got funding, but I did gastroenterology, and really everything I did consolidated that theory. And I came up with a couple of good treatments, diagnostic tests. It was all part of the equation. So
The breath test, right? Yeah.
So then you've got a manpower problem in Royal Perth Hospital, because I'm looking for patients to go into my clinical trials. So of course, I call up Alison Fan, and she was a Channel 7 news reporter, and she'd had gastritis or ulcers or something. I can't remember whether she had Helicobacter when we were just experimenting. So she was a bit interested, and I called her up. So she then ran out with Channel 7 crew and did an interview with me about the new research program for ulcers. And I was just myself with no support. I just had my salary and a few thousand for bits and bobs. But I had a computer. That's always been my hobby, electronics and computing. So I built a computer, and then I bought an IBM compatible in the very early days.
Yeah.
What year was that, sorry?
We started our research in 81. So 81 was IBM's.
Yep.
So I had my own computer at that stage. So I published my first paper on that. It's a thing called CPM and WordStar, if you've ever heard of that, and 24K of RAM. So 24K means it's got about 4 pages of your document. And then it has to go and load the next bit. If you're scrolling through, it has to get more off the disk. So it's kind of slow, but we thought it was great. And we had DBase, so I was able to manage a database with 500 people on it. And so once that publicity got out, everybody with an ulcer in Perth started calling Royal Perth Hospital. And that, after the Sunday night report, might have been 60 Minutes, I got this complaint from the medical superintendent's office. Dr. Marshall, you were on TV last night. No one can call Royal Perth this morning. All the lines are jammed trying to get into your study. There are these crazy people calling up, I've got to see Dr. Marshall. And so I was pretty calm about it all, because even then I was starting to work from home a lot, but I had an answering machine, a DBase computer, and all kinds of automated record keeping. No one had that.
Yeah.
And I was probably the only doctor in the whole hospital besides the medical superintendent, but he had about 5 secretaries working for him, and they had one word processor between the 5 of them. So I was computerized, and I was handling these 500 patients and managing a waiting list and all kinds of stuff like that. So caused some problems. But then I got funded, and we treated people with antibiotics. And what we found was that if we could eradicate the bacteria, the recurrence rate for the ulcer was only about 10%. If we didn't eradicate the bacteria, it was 80% in 1 year. So it was almost an absolute given that you would get your ulcer back. And so the disease hadn't been controlled unless we controlled the bacteria. So that was a great story. But of course, to do all this, I needed a full-time secretary and 2 full-time nurses. Everybody needed to come in and have an endoscopy. Whereas if you went to your GP and said, "Oh, I've got a history of an ulcer, I think I've got it back," GP would say, "Take these tablets. And after 3 months when you run out, I'll give you more." So that was like a 10-minute, it's like your early asthma prescription, if you like. Okay, asthma drug, get out of here with your puffer. That was like that for ulcers. But to actually cure the ulcer, you had to get the germ and you had to culture it and give the patient antibiotics, and then you had to do another endoscopy a few months later and follow them up and treat them again until you had the right treatment. So how could you solve that problem? Well, lots of doctors wanted to treat ulcers, but they could not find nobody believed it. So if you said, "Oh, Barry, I trust you, I really want to do this," I say, "Well, you've got to find a pathologist who can see the bacteria, and you've got to send the specimens to that pathologist, and then once you've got that partnership, then you're going." But a lot of people couldn't really, as gastroenterologists, they couldn't find the right partner who believed in the bacteria, if you like. And so what I invented was a thing called a rapid urease test. So you could exploit the fact that bacteria generated ammonia. That's how it protects itself from acid. So you could take the biopsy, stick it in a test that was just really a fancy litmus test. And if it changed colour and went red in 10 minutes, there's no doubt you've got the bacteria. It was like 95% accurate. So a gastroenterologist then could buy that test or use that test, and it was his one-man team to treat the bacteria and cure ulcers, you see. So that took off. Delta West patented it, and we're manufacturing it and exporting it to America and things. And we still make it.
Yeah.
It's still on the market. Kimberly-Clark sells it now. But then when the patient came back, I had to do another endoscopy, you see. So, of course, my endoscopy load to see 100 patients was 300 endoscopies, whereas a normal gastroenterologist would just have 100 patients, 100 endoscopies. And the other point was he wasn't curing anybody. So those patients would come back a year later and have another endoscopy when they got their other ulcer back. And so that there was no incentive for the medical profession, the gastroenterologists, to cure people.
And what it was about back at the time, it was about $700 for an endoscopy. Is that roughly?
Yeah. So so now it's still similar. It's about $1,000. Yeah. So it's like $400 to the hospital and $400 to the anaesthetist, maybe, and $400 in your pocket. Yeah. Your gastroenterologist. So something like that. So it was similar. It was a pretty high-tech procedure and sort of a little bit dangerous, if you like. Because ulcers always came back, a gastroenterologist, once he'd got 100 or 200 ulcer patients on his books, he didn't actually have to collect any more patients for the rest of his life. They just kept coming back. So it's like a chronic illness. Yeah. It was like, "Oh, yeah, Barry, you have to manage it. It's a chronic illness." Blah, blah, blah. So I didn't believe any of that. So I was curing people. And so effectively, in the future, as soon as we started doing it and getting such good results, Robin and I could predict that the income from upper endoscopy and ulcers was going to decline dramatically once this happened. Well, it took a long time for it to happen, 15 years before it was really becoming mainstream. So in some ways, the gastroenterologists were correct. They finished their careers and retired in time, and then the GPs were all treating the ulcers after that. But one of the things was the breath test, because, so I said Helicobacter secretes ammonia. So the other part, it splits urea, which is a waste product in your urine. It's in all your body fluids. The other part of urea is carbon dioxide. So if we labelled the carbon in urea with a isotope, carbon-14 was the first one we used. Then we used C13 as a non-radioactive one. So carbon-14's got the advantage that it's only a 10-minute test. You can do 6 people at once. It's much cheaper, and the radiation dose is less than you get from 1 hour in a plane. So it's unregulated in the United States. You know, you give it to anybody, pregnant women, children, everybody can have it. And so that one came on the market, and the carbon-13 is a bit more technical because that's a mass spectrometer and things involved with it. But effectively, you take some urea, and after between 10 and 20 minutes, you might take a breath sample or a couple of breath samples and put them in a machine. It says the labelled carbon dioxide is coming out in your breath. Mm-hmm. So that means the chemical, urea, that you swallowed is being split up in your stomach to CO2 and ammonia, and then the CO2 goes into your blood and comes out in your breath. So it only takes 5 or 10 minutes to happen. Yep. And so it's a very, very accurate test again. So the breath test, I patented that in Australia and the US. It's now, each of these tests sells about, well, at least 30 million a year around the world of each one. And they're all generic now, patents expired, etc. But they are the mainstay of the H. pylori diagnostic business. Then there's serology, blood tests for it. So what it mounted, once you had those tests, once you had the diagnosis, the tests, and the treatment, you can hand that as a package to any doctor. Mm. And instead of having to learn all this waffle about stress and ulcers, I actually measured it was 114 pages in the textbook before I started, and it was 4 pages after I started. So ulcers,
God bless you,
peptic ulcers. So for each medical student, he could go to the beach for that weekend instead of learning it. So I remember how darned hard it was when I did my surgical exam, because you had all these different types of surgeries and all these things about how to measure the acid and all that. I learned quickly, though, that to learn surgery, all you had to do is look at the pictures and read the captions. Yeah. So flick through. Most of it was pretty straightforward. And then a few tricky ones that you had to know. But it was a skill set. If you were skilled, you did well. Mm. So I still like surgery. It's a release, but I don't do much of it anymore.
Yeah, yeah.
Now, is there any reason why that bacteria proliferates in the stomach, or is there any benefit to it even being there in the first place?
So nowadays when all that's water under the bridge, I thought, ho hum, everyone knows about Helicobacter. Yeah. Read those 4 pages. Yeah. The controversial thing developed because it turns out most people in the world were infected with it. Yeah. So in some ways that's a disadvantage. It's great because, obviously it's an important disease, but the disadvantage is it's hard to convince people that something that everyone's got is important. And 80% of people with Helicobacter don't have any symptoms. They never got ulcers. They just pass it on to their children, and you probably catch it off your mother when you're about 2 years old. Humans have had it for 100,000 years at least. Mm. So what's going on here? And it does have subtle effects on your immune system in different ways. And getting back to asthma, which seems to be popular, they found out that children in New York City who had Helicobacter had about a 40 or 50% reduction in the amount of asthma, eczema, hay fever, all those kind of allergic things. And perhaps the Helicobacter modulated your immune system. So the question is, what normally happens when you get infected with the bacteria? Well, your immune system comes in and kicks the bacteria out effectively, or virus, and you develop some antibodies and some immunity. Alternatively, your immune system's not strong enough. The bacteria build up, get into your blood and kill you. Mm-hmm. Yep. That's the other side of the equation. So it's very unusual for a bacteria to infect you and then be present in your stomach in massive numbers, like 1 billion, more than 1 billion probably, lining your stomach, and to sit there quietly for your whole life and you didn't even know you had them, although you might get an ulcer. So that means you've got to have, it's an engineering concept, you've got to have some stimulus and you've got to have positive and negative feedback.
Yeah.
So on one side, you've got the bacteria hammering away at the wall of the stomach, and they want to make some little leaky holes so iron and different things will leak out from your blood, from your tissues, and nourish the bacteria. So they're plastered and stuck right on. They have sticky things called lectins on their surface. So some bacteria will stick to humans. Some bacteria won't stick to humans. They'll stick to dogs or rabbits. Same with viruses. So this is why different animals have slightly different disease spectrums. And you can't necessarily catch swine flu from a pig, except when it mutates. So the Helicobacters, they're stuck in the stomach, getting some nutrition, and this irritates the lining. Your immune system then becomes super active. Now, if the immune system went hyperactive and crazy, it would then be too active. It would cause an ulcer. So people with ulcers are actually the super healthy people.
Yeah.
And that's why ulcers developed in the 20th century. We had never been so healthy.
Yeah.
And people in Chicago, the big businessmen, they're eating those aged T-bone steaks and all this kind of stuff, massive amounts of protein, acid levels are higher, strong immune system. And these people are getting the duodenal ulcers. So obviously it's caused by the 20th century, but it's not what you think.
So in the tropics, it might be a benefit because there's a lot of foreign pathogens. Or say 20,000 years ago.
More complicated. So the other paradox is, what about people with AIDS? They've got no immune system.
Yeah.
Have you ever heard of a person with AIDS getting an ulcer? No. So the paradox was that people with HIV and in the AIDS hospital and everything, they never had duodenal ulcers. And people were on chemotherapy, they don't get ulcers much. So if you put all that data together and realise that ulcers are caused by a really strong immune system, well, the negative feedback on the immune system to stop you from getting an ulcer and dying, is that the bacteria inhibit the immune system.
Yeah.
And they recruit certain suppressive cells like control, I forget what they're called, certain lymphocytes that control the immune system to make sure it's not too active. Plus, they have toxins which make the dividing immune cells go to sleep, rupture early, apoptosis it's called, and it's a programmed cell death. So certain things can trigger a cell to suddenly go rupture, blow itself up. And so chemotherapy works a lot like that. So the H. pylori's got these negative feedbacks on the immune system. It doesn't want to get eradicated, but it doesn't want you to get an ulcer, because then you'd be eradicated and that'd be the end of it. It wants to sit there and slowly infect the next generation. So that's exactly what happened. And everyone said, well, okay, so many people in the world, billions of people have H. pylori. Maybe it's got a useful purpose, and maybe it's related to this modulation of the immune system. And so that's why people in developing countries never used to get ulcers very much. They had H. pylori. They had probably a lower level of acid secretion because it does actually lower your acidity in some cases. It damages the wall of your stomach. You can't make much acid. And thirdly, so I said, suppresses the immune system and you can't make much acid. So what advantage is that? Well, I just made something up, but I could think of a few reasons why it would be useful. And one of them might be that, when humans developed in Africa for a couple of million years, they're just living in a 100-mile radius in Ethiopia or somewhere like that. Yeah. And so they were exposed to things there, animals and plants in that region. So then when the seas dropped during one of the ice ages and they headed off into Asia, now they've got different animals and different plants. They've got pollens up in the northern hemisphere. There's all these grasses and pine cones, all kinds of things that you can get allergic to. So maybe it was an advantage not to be too allergic. Yeah. You're hiding in the bushes. There's a few lions walking past. All of a sudden, achoo. Yeah. That's going to be negative.
Yeah.
In fact, there is data on lion helicobacters that they're actually human helicobacters that crossed over about 150,000 years ago.
Oh, wow.
Into lions.
Yeah. So the lions ate the humans and picked up the Helicobacter. Yeah. And
That's
now it's mutated in the lion. So it's still Helicobacter, but it tends to be less toxic. It hasn't got the toxin genes anymore.
Yeah.
There's a lot of subtleties like that that keep us interested in it. So we're studying the DNA. We like to know why some people get ulcers, why some people don't. Does it affect your immune system? And the company that I had called Ondec's in hibernation at the moment because we kind of run out of money and it's very, very expensive to develop what we're trying to do. But we're going to raise from the ashes. And the idea is to take a killed Helicobacter product that make it available as like a food supplement or a probiotic so that in the 21st century, Australians don't have Helicobacter, and maybe they're a bit too allergic. So that if you had that tendency in your family, potentially you could take a few grams of powdered Helicobacter extract, put it on your Wheaties or on your children's Wheaties in the morning, and maybe get some of the immune benefits of Helicobacter, but you wouldn't get an ulcer or an infection or anything. So it'd be kind of a harmless food supplement.
Because it wouldn't colonize, it just sort of pass through as a
it'd be
regulatory thing,
bacteria in suspended animation or chopped in half or killed in some way. But we found that it was quite difficult to do because you have to kill the bacteria so it's not infectious, but not change it because you want the immune system to think it's alive.
Yeah.
And so ultimately, it might take us a few years. So we're rejigging the research program. And ultimately, it could be that we'd be making tons of this stuff. Mm-hmm. And it would be added into some health food products, things like that, if you're a bit allergic. Making it in this special way in large amounts is the trick. So once we've solved that, well, then everybody who's interested in allergy research or immune research will be able to test it out.
Yeah.
It works in mice.
Okay.
That sort of reminds me of the whole probiotic sort of industry now. I've been reading a bit how it seems like it's very hard for it to be, I guess, bioavailable or for it to survive, to colonize, and it seems like a lot of them just work as sort of a passerby, sort of a regulatory thing, and it's very early for a lot of the claims that sort of happen in some of the probiotic.
So I've been on both different sides of the regulations. So for something to be a drug, you've got to do massive amounts of safety testing, and then you've got to show that it's efficacious and harmless. But if you can get something in as a food product, well, with drugs also you have to do double-blind controlled trials. So you want to get real data, and then the benefit of that is the pharmaceutical benefits scheme will give it a tick, and it'll be reimbursed by the government. It'll be $30 instead of $300 because it'll be subsidised.
Yeah.
However, if you have something that's classified as a food product or a food additive, you only have to have one publication in a not very scientific journal that just scrapes in with a p-value of 0.05. And you can go crazy with the marketing on that. Oh, it's scientifically proven, you see. So, if the p-value is 0.05, that means randomly 1 out of 20 will work.
Yeah.
So you just keep trialing, and eventually someone does a study and with a bit of luck gets a p-value of 0.05 for this food product. All of a sudden it elevates it up to majestic heights, and it's a probiotic that improves your gut health or something vague like that. But you're right. When from time to time we, in my lab, the H. pylori research lab at UWA, we get the scientists on to looking at a probiotic product or something, and it's very hard to keep those bacteria alive sitting on the chemist shop shelf for 6 months. So they start off with 1 billion. By the time it's packaged up in the capsules and distributed, you've got something like 10 million. As soon as they go into your stomach, the acid kills most of them.
Yeah.
You've got 500 or something. And then do they actually get to the other end as live bacteria?
Yeah.
So, of course, the one that really does have live bacteria would be a yogurt.
Yeah.
Because you've got billions of bacteria in. They get in, and probably 1% of them survives into your small intestine and have a slight acidification from lactobacilli or something down there, and they're pretty harmless, and they may protect from other bacteria that are living there. They're not as happy anymore with the lactobacilli around, and so you end up with a cleaner small intestine, and you absorb your food in a more natural way, etc. So there is little bits of scientific evidence to all of these different things. And these days you can actually measure it because you can take a stool sample and measure the microbiome. And there are probably 1,000 different bacteria living there. And we can only identify 300 of them. Probably 100 of them would make up 99%. The next 100 would be the next, 1%. And the next 100 would be the 0.001%. So only in the last 5 years have you had machines that can actually measure that small amount of DNA and separate it from the masses.
Yeah.
And so it's like that cartoon, Where's Wally? You got all these people at footy or something. Yeah. Somewhere is Wally. So that might be the key germ that you need in your microbiome to make it work better. And so that potentially could be wiped out by an antibiotic, or you change your diet, or you've got gastroenteritis. So a lot of funny gastrointestinal diseases could be related to the microbiome in some way, like disturbed metabolism. And so all these bacteria, they're in a chain, and your food comes in at the top, it gets digested, you've got the most of it, and then it goes into your colon, and obviously a whole lot of bacteria like E. coli will grab hold of it, and they're present in masses, and they have various waste products. So each of their little bacterial waste products has then got another type of bacteria that's latched onto that food source. And so it goes on ad infinitum, if you like. So that you're not just interested in what bacteria there, you're interested in all the different chemical reactions that are going on in your gut. And if you look hard enough, and some people have got papers on this, that you can sometimes find bacteria that are making a waste product that goes into your system. Like it could be something like a hormone, or it could be something like a vitamin or a nitric oxide or something.
I've heard they can produce GABA and serotonin and all that.
Yeah. So anything that's produced in your gut is supposed to go into the veins in your intestine, so it gets absorbed. And then it divides up into capillaries again in the liver, and your liver cells are supposed to take it all out. So if you had a funny blood vessel, or if you had cirrhosis or liver disease, or if you had there's different places in your body where the liver can be bypassed and it can go into your main circulation. It can float up then as a native molecule and perhaps affect your brain. There's some sort of subtle hints on various diseases about that. So it's really wide open at the moment. I'm telling you, it's extremely overhyped.
Yeah. All sorts of things linked to it, but it could be indirectly linked to it.
So it's like taking vitamin C for colds. Well, it's not going to do you any harm, and they taste okay, those vitamin C chewables. Okay. So I don't really put a grudge against anybody who does that, but I can tell you there's absolutely no proof that it makes any difference, and most 99% of it just comes straight out in your urine if you take mega vitamins. And probiotics is kind of the same. If you eat a balanced diet, you probably don't need them. I see people who took antibiotics and maybe got a slight imbalance, and I encourage them to take probiotics, but I can tell you there's not really solid proof in a pharmaceutical regulatory way that these things cause you to definitely feel better. Yeah. And obviously you take them for gut health, but how do you know whether your gut health's abnormal or not? Might be set. It's set sort of by your diet. So
very specific
all these things
to an individual.
Yeah. So I think it's a science that's developing, and probably 10 or 20 years from now, you will be able to be more specific about it. Yeah. But at the moment, it's the froth on the top of the beer, if you like, as far as your health is concerned. And if it's totally safe, that's great. Actually, I'll have a little mini campaign right now about this. And I told you that a little bit of data creates massive amounts of advertising and marketing. And if you watch daytime TV, you'll be extremely shocked as what's being sold there with health claims. Glucosamine, shark cartilage, slimming tablets, all these kinds of different things. So one of the problems I have with those products is that they are not proven in double-blind studies. Yeah. Yet they're taking $3 billion a year out of the health system. the thin edge of the wedge is that some of them are now getting indications and are getting subsidised and paid for by the PBS. So some of the medical things that the government pays for have never been proven and probably never will be, because we don't want to test our product. We're selling $1 million a week. And if we test it to prove it through the university's research, what if it doesn't work? And everyone will know that it's bogus, you see, so we wouldn't want to do that. So I would say that what we have to do is anything that's got a health claim, I think it should get another 10% tax. So at the moment, maybe they pay GST, maybe they don't, but I think they should get another 10% tax, and that would generate another $300 or $500 million, which would go into medical research. And so then I wouldn't be whinging about the fact that everybody's spending $100 on unproven health vitamins or something and complaining that they're paying $30 for an antibiotic that's really going to work. At the moment, there's pressure from China. There's pharmaceutical companies in Australia that make a lot of money in China into this alternative kind of market.
Herbal supplements.
Yeah, herbal supplements. Australia is squeaky clean. It's an island, there's no diseases there. It's great, pure, got good cachet to it. So Australian products in China and around the world have a pretty good reputation. That's great. But they're going into this sort of natural therapy, alternative health market. So the other side of the equation is that the alternative health market in China, which is probably 50% of all health, is going to be trying to come into Australia. And not only that, a lot of people think that these things are proven, so they're quite happy to get the pharmaceutical benefits to start paying for them. And, there's never enough health money to go around. There's always rationing in some areas. So, when I see things like acupuncture being included in a subsidised medical scheme, if it's extra and you pay for it on your own private health insurance, great. But I don't want to see anything that's not absolutely proven subsidised by taxpayers. Yeah. So that's why, and in China I say the same thing. I say, the problem with alternative medicine is not proven. And some of it might work, but we don't know which bit. So it's important that the natural therapy medicine does plenty of research, finds out if there is something in there that's active, find out exactly all about it, do the double-blind study to show that it's proven, and then the government will pay for it. Yeah. So that's the wonderful benefit of it. But the government should never pay for anything that's not proven. Otherwise, there's no end to it. Yeah. And so I think everyone needs to be alert to this kind of pressure that's going to happen in the Australian government both ways. So if companies in Australia are selling natural products in China and making a bomb, all their shareholders in Sydney, wherever they might be, are getting rich. Mm-hmm. They don't want any extra taxes on that kind of product. Yeah. And they will be leveraged to let the Chinese natural products in without any extra taxes. And they'll be interested in getting the government to pay for that product as well. So I'm pretty nervous about that at the moment. And I think some of these things have already happened, the thin edge of the wedge, I'd say. Yeah,
what you're saying really appeals to me and my objective mindset, that it makes perfect sense to me that we should be reallocating more resources towards research and evidence-based exactly that. So that makes perfect sense to me. And is that how much of that right now and trying to influence that takes up a lot of your thinking, a lot of your time? Are you working quite hard towards achieving this?
Well, I'm a member of the Australian Skeptics, and if you get their newsletter, I suggest you should sign up for it and just read it. They'll report, the anti-vaxxers, vaccine people, all this kind of stuff that's going on, weird chiropractic practices, stuff like that. So you need to keep tabs on it, because there's pressure groups and politicians. You don't necessarily become a politician because you did science. There's 20 other reasons why you might be a politician. So we need to keep an eye on it and try and keep Australia squeaky clean and make sure, I don't want to discriminate against any other country. So it's important that we have the rules and we stick to them in Australia. Say, that's the law. And someone says, Barry, we want to bring our product in here. Will you endorse it? We'll give you money, all this kind of things that would happen. And I get an offer like that every week.
Yeah.
I could earn a living promoting shark cartilage or something like that if I wanted to. But, I draw the line at that. So, that as long as Australia's got this strong legislation about evidence-based, evidence-based, and there's a bit of a penalty that if you've got a health claim that's not evidence-based, you pay the extra 10% and that goes into the research. And then if it works, well, now you can put that health claim on your product and you can take the 10% tax off. So there'll be a lot of stuff which is grandfathered in. It's been there forever. But as soon as you want to say that it cures your arthritis, okay, how does it do that? It strengthens your immune system. Exactly how does that happen? What is real and what's in your imagination? Or it gets rid of acidity out of your system, all this kinds of stuff. So, it could go on. You could go on and on about this.
Detox products.
Yeah.
As an anecdote, at Chemist Warehouse, they sell homeopathic versions of, say, melatonin, etc., supplements like that. And they don't really list it that much. Like people buy melatonin, which I don't know really if that works that well anyway. And they'll realize later that it's like 1/1000th or 1/10,000th of the strength. And it's just not really advertising. It's like, how does Chemist Warehouse sell that?
So the other thing that's often spooked with the natural medicine is, there's a 3,000-year tradition of this use of this stuff for fevers. Oh, yeah, okay. Well, that tells me it's probably safe. It's just some vegetable or something. It doesn't tell me anything else about it. It doesn't tell me anything about the efficacy of it. And remember, when these natural therapies were developed, you didn't have anything else. And everything was caused by stress or emotional problems or cosmic rays or gods did it to you or someone pointed the bone at you or there's evil stuff happening, all that kind of thing. Well, we've moved on. And we're a 21st century country. And people in other countries, when they look at Australia, I think they see Australia, they probably see Sweden. It's sort of on the same level. Sweden's up in the northern hemisphere, more connected, and the Nobels flow out of Sweden, and so that occasionally they screw up. Or it's a few times in the last few years, but mostly there's a very high standard there. The other good example, although there's massive amounts of bad publicity flows out of America, unfortunately. There's a lot of important good stuff that is in America. And when, what was it, LBJ, I think it was. So when LBJ in the 60s was in, he brought in Medicare, which meant in America, although medical care is expensive, et cetera, people who are above the age of 65 get public health. It's free. So that's like a third of the whole population or something. So massive numbers of people. But they had this argument about what things was Medicare going to pay for.
Yeah.
So there's no limit. We'll go broke in 5 minutes. And one of the things that was on the market, this is an ulcer story actually, was that they didn't have any way of stopping ulcers. And people were dying from ulcers and having bleeding ulcers all the time. And someone got the idea that you could put ice water into the stomach and then the coldness would constrict the bleeding vessels and stop the bleeding. So that the issue was, surgery was pretty dangerous in the 60s. It was, twice as dangerous as it is now, probably more so. Lots of ulcers. So they said, well, what's the best way of putting ice water in the stomach? This works in experimental dogs or something. So you would come in with bleeding ulcers, you're getting all these massive transfusions and getting hepatitis 6 months later, of course. So you go into the emergency room and the surgeon will say, oh, look, I'm doing a couple of procedures. I'm not going to be finished till 3 a.m. Can you give him an ice water stomach lavage? So they would put a tube down your throat and pour in ice water. Actually, this is still in the medical books.
Oh, wow.
So then what happened, someone in Minnesota said, well, that's a bit primitive. What we need is a better controlled ice water lavage. So he built this thing about the size of a massive washing machine that's got all these tubes and buckets of ice in it, and mix it with alcohol. You can get it colder without freezing.
Yeah.
And they had alcohol-based ice water, and they would put a hose down with a balloon on the end of it, and then this machine would automatically circulate very freezing alcohol solution, like antifreeze or something, through your stomach, and it would stop the bleeding. And then you would stay alive. The surgeon would take your stomach out at 3 o'clock in the morning or tomorrow or something. So that was great. So this became very popular, and they sold about 20,000 of these machines, and surgeons were driving around. You could fit them in the back of a ute, I think, and hospitals would, we must have one of these machines, save lives. So the Medicare came in, and one of the things on their list that everyone wanted to pay for were these $20,000 machines, which in the 1960s, that was like $150,000 or something nowadays. And so all the surgeons, we must have these machines, you've got to pay for it. But they stood firm. They said, we're not paying for it until it's proven. So you have to do a double-blind study.
Yeah.
So everyone's like, it's a given. So they found the proponents were all in the Mayo Clinic. So everyone else hated the Mayo Clinic. So the guys in Texas and California and Massachusetts, so they were extremely jealous of the success of this gadget over at Mayo Clinic. So they did this study where they got the machines and they put a couple hundred patients through it with bleeding ulcers. And they did a placebo-controlled study. So half of the people, they just gave normal temperature saline through this balloon.
Yeah.
The other half, they gave the ice water one. And guess what? No difference.
Yeah.
You see, so the whole thing was never paid for by the government. And so then the government said, right, that just proves that we were right. No matter how obviously fantastic a new treatment is, it really has to work pretty hard and have good double-blind data before the government will pay for it. Otherwise, we'll go broke. And so time after time, you've seen this, and you say, why is the US government funding a $20 million study on some treatment when obviously it's great? Why not save the money?
Yeah.
Well, the answer is that it could be $2 billion in 5 years' time if you didn't do those studies. So that's the basis upon which every other regulatory system, like Australia's TGA, for example, they're strict. They say, right, these are the rules. And someone says, can I get my local politician to write a letter to the health minister? And everybody says this is going to be great. So they're writing letters, they're pulling strings, trying to get the law changed, the rules changed, and there is a bit of that goes on, I can tell you. But inside the TGA, they're a bunch of really mean scientists. They say, there's only one thing you need to do, Barry, show me the data.
Yeah.
And so I had to go through this process. It was painful. It meant that we, spent $500,000 getting the breath test, for example, on the market and regulated properly in Australia. We had to employ 2 people for 18 months and pay all this money to the TGA and scientists and things. And the test was already in worldwide use in different ways. But now, we have a test that's on the market and it's reimbursed.
Yeah.
So that's where you want to end up, and your GP can get it. You can go and have one. And it costs you, I don't know, nothing probably. So that's where we want to be. That's where we are. That's where we want to stay.
Yeah.
So would you say, instead of micromanaging yourself with supplements you read about on the internet, you should at least just start at a healthy diet with all the micronutrients you need? Just be there instead of...
So there's more and more data that...
with proven medicine.
Yeah. So how does diet affect you? Well, you want to have the right balance, perfect nutrition. So you do want to eat the different food groups, and you probably want to cut down your sugar compared with what people used to have. So we have diet drinks, so you drink water or something like that a bit more often, not so much sweet drink. Don't put sugar on everything, maybe sometimes. It's sort of an indulgence rather than part of daily life. That'd be fine. And once you're adult, once you're in your 20s and 30s, start getting your cholesterol checked every now and again, your cholesterol and lipids and things. See if there is something that puts you in a high-risk group because it's genetic. It's not really what you eat.
Yeah.
So then you may not take a statin, depending on what your risk is. You get your blood pressure checked, and nowadays they say even a little bit of high blood pressure is not good. So really 130 on 80 is where you want to be. And I'm sort of, when I take a statin and an antihypertensive, and so I'm sitting between 130 and 140. If I take any more, I might feel a bit dizzy if I don't eat breakfast, so I don't go any stronger than that. My statins level's great. And keep your weight down, do regular exercise within your limits. So that's 99% of it. Do I or do people in my family sometimes take vitamins? I don't know. If I look in the cupboard and I see a multivitamin there, I think, oh, gee, I've been on a few trips. I'm probably a bit deficient. Chuck one down, but it's not really part of my life.
So I do that as well. I actually I'm interested in supplements because I don't try and attach to it too heavily because, as you're saying, there's not a lot of evidence around it, or if there is, it hasn't gone through enough. But it is very interesting, and I try to experiment just to see what happens. Very mild things like creatine, obviously, etc. So yeah.
And there's a lot of science in it these days. It's a fine line between what's a supplement and what's a sports enhancing drug these days. and I think the situation over in Brisbane with the rugby teams was that don't ask, don't tell. If it's not listed as a forbidden drug, that's okay.
Yeah.
It might not be true, but in the future, you're interested in that? Well, you would be able to. You can do it now. It's quite expensive, but you can get your microbiome checked, and it's got. It's more natural to have not so many E. coli or Firmicutes or different ones there, but usually, it gets modified by your diet. So you change your diet, it'll change in a different way.
Environment, does it affect?
Usually, I think it's just diet.
Yeah,
the environment inside your gut is the same, 37 degrees.
Yeah,
not too much oxygen. And
say if you're someone who lived in the bush, which doesn't really happen that often anymore, would your microbiome be any different to someone, say me, living in a suburb?
Probably not much different.
Yeah.
If you lived in Africa and lived a bit rough,
or parasites,
you'd have all kinds of worms. Like in African countries, everybody's got worms. Some of these are serious public health problems. Like a couple of years ago, I went with Dr. Digby Cullen to Madagascar, and they have Schistosomiasis, or also called bilharzia, and that is the snails have a parasite. It bores through your skin, goes into your liver and everything, and your liver packs up, and it's carried on. And the other host is water buffaloes. So any kind of country where they're using water buffaloes and people are walking around in bare feet through swamps making rice or whatever, they're all going to get it. So in China, there's a province, a city called Guangzhou that I went to, and they've wiped the disease out. What do you reckon they did?
They
killed all the water buffaloes and ate them. All the water buffaloes have been turned into hamburgers.
Whoa.
And they gave every farmer a little gas-powered tilling machine. He can do twice as many paddocks in the same amount of time now with this little machine. Yeah. It's much better. And there's no more of that disease in that province. So obviously you've got to get the main thing is to try and do things which raise the standard of living, and then that people can use technologies that will solve a lot of these health problems.
I'm actually going to have a conversation with my GP today about a stool sample that I provided them, but they wouldn't normally look at your microbiome if you didn't specifically ask for them to do that.
Yeah, it's not
just a standard.
Very specific companies that do it.
Right.
Yeah, so you can get it sent off, and they will find all these different bacteria and traces of things there. Sometimes I wonder about the quality control. They haven't got the big pathology lab oversight quality institution testing them and checking on them, so they can report polymerase chain reaction results and find bits of DNA and say you've got this. It's not really proven. Typically, what happens with a stool sample is you're looking for parasites, and so several things happen. You look for white cells. So if you've got any kind of inflammatory disease or some germs, Campylobacter, the other ones, can cause white cells in the stool, things like that. So white cells or their products. And then all kinds of worms produce little eggs that come out in the feces. So you don't usually see the worms, you see their little eggs. And so if usually you do 3 stool samples, and so that you've caught it. If it's going to come down intermittently, usually you'll see it there. But I can tell you that when people go on these big cruises and everyone on the boat got sick, 900 cases of gastro, something. So something was contaminated. When you follow those people up, 10 or 20% of them are left with some abnormality of their gut. They say, I used to go to the toilet, 5 times a week, 7 times a week. Stools were always normal. I could eat whatever I wanted. Now, if I eat certain things, it seems to go straight through me. I would randomly get diarrhea, that kind of stuff. And it seems to have started 3 years ago when I did this. And I know a guy who went swimming in the water near Hiroshima. Oof. And so maybe it's not radioactive, it's just germs in it. There's so many, 50 million people live nearby. And he got some gastro from that and it never got better. And I couldn't find anything wrong with him on all these tests. So we'd say he's got irritable bowel. That's my other research at the moment. We've got a special stethoscope, computerized artificial intelligence system being evaluated, where you clamp it on, it listens to all your bowel sounds for a few hours and works out which part's malfunctioning and tries to make a diagnosis of irritable bowel or something else. So that's called the Noisy Guts Project. Anybody who hears this should check up the UWA website, look for Noisy Guts on YouTube. You can read about it, and Excellent. You could be a volunteer. So that'd be great.
Actually, while we're on a roll with that, is there any other things you wanted to talk about in terms of like just plugging your own sort of what you're up to and different websites or various things? Or
we have various different websites. We've got a website for Noisy Guts, I think. We've got the Helicobacter Pylori Research Lab, and I've got a good forum there. It's been going for more than 20 years. Yeah. And people can put their case records, ask questions about antibiotics. If we find that it's getting a bit spammed, we block all these spammers, but we've got security for that at the moment with captures and things. But we also have people who are a little bit crazy about natural products and organic products as they go. They're obviously right into that, and they'll start trying to teach everybody how to do it. And we might block them or delete them. Other times, if we think it's totally bogus, we just colour the background pink on that forum entry. Give a bit of a warning.
That's great.
So it's fun. It gives you a lot of power actually to manage a website like that.
Yeah. So your message for those sort of people would be sort of do your research and be objective and maybe not jump to conclusions too quickly.
Don't spend too much money on it.
Yeah. Oh, this has been a really riveting chat. Actually, we've covered a lot of ground, and it's an absolute pleasure to get you in and talk to us. And you've achieved a lot of amazing things, and you seem like a man of extraordinary integrity as well. So thank you very much for coming in. We've really appreciated this. It's been great.
Okay, thanks very much for inviting me.
Cheers.